like 30. All right, so for this problem, you do have to FOIL this because special products only work when you have the same binomial or they're the same binomial with opposite signs. In this case, we have totally two different binomials, so this one we're going to FOIL. Remember, when you are multiplying different terms, you multiply the coefficients. So 7 times 2 is 14. I'm doing x squared times x squared, which would be x to the fourth. And then y times y is y squared. Then we need to go to the outers. 7x squared y times negative 3 would be, again, I'm just doing 7 times negative 3, so negative 21 x squared y. Then I go to my inside terms, so 1 times 2x squared y, which is positive 2x squared y then. And then 1 times negative 3 is negative 3. And we would have middle terms that are like in the middle. So we'd have 14x to the fourth y squared. Negative 21 plus 2 more would be negative 19 x squared y, and then minus 3. Okay, so again, that's FOIL, but it does have two variables within it, so that can make it a little trickier. All right, so today we're going to talk about Pascal's triangle. So if you watched the video yesterday, that short video, it just is kind of showing you, the only thing you really need to get out of that video was that there is such thing as Pascal's triangle, how it's kind of created, and that there's a ton of different uses out of it. Okay, we're going to look at just one of the uses, but if you watch the video, it says there's like a ton of different uses out of it. So we're going to use the most common use of it though. So, all right, so the first thing, Pascal's triangle. It starts off with row 0. Okay, that's important to know. You need to start off with row 0, which is just a single 1. And then it goes down to row 1, and the rows always start and end with 1. So it's kind of, the 1s are coming out. And so as we go to row 2, again, those 1s are coming out. But the way we get this term is you add the ones kind of pointing to it. So here I'm going 1 plus 1 to get 2. And as we go to row 3, that 1 comes down, and then I'm adding the two numbers between it. So 1 plus 2 is 3. 2 plus 1 is 3. And then I bring this 1 down. For row 4, again, this 1 just keeps going out diagonally. And then I would do 1 plus 3, which is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then this 1 comes down diagonally. Okay? So try and make row 5 and row 6. Row 6, you're going to have to kind of bring on your own. So row 5, this 1 comes down. We're adding 1 and 4 to get 5. We're adding 4 and 6 to get 10. We're adding 6 and 4 to get 10. We're adding 4 and 1 to get 5. And then the 1 comes down along the outside. For row 6, this 1 slides down. And then I'm adding 1 and 5 to get 6. Adding 5 and 10 to get 15. Adding 10 and 10 to get 20. 10 and 5 is 15. 5 and 1 is 6. And then 1 along the outside. Okay, so one of the uses of these numbers is they are the coefficients of the binomial expansions. So if you look at a plus b to the 0, anything to the 0 power is 1. So we have a 1 at that 0. For the first power, if I take anything to the first, it's just itself. So there's a 1 in front of each of the a's. Notice row 1 is a 1 and a 1. For a plus b quantity squared, notice the coefficients. There's a 1 in front of this a squared, a 2 in front of the ab, and a 1 in front of this b squared. We look at row 2, it goes 1, 2, 1. All right, look at row 5. Here, the b to the 5th. There's a 1 in front of the a to the 5th, a 5, and then a 10, 5, 1. If we look at row 5, it goes 1, 5, 10, 10, 5, 1. Okay, so these numbers in the triangle are those coefficients for the binomial expansions. Okay, so then how do we get these other letters? Like, how do I get a to the second, and then ab, and then b squared, or a to the third? How do we get those? So we're going to start here. Okay, so other important patterns in the binomial expansion of a plus b to the n. So the total number of terms is always n plus 1. So n is whatever your exponent is for that binomial expansion, and then you'll always have one more term than that. So if you kind of look here, the exponent was a 2 here, and we have 3 terms. Right here, the exponent's a 5, and we have 6 terms. Okay? So you always have one more term than your exponent. The first term then is always 1 times a to the n. Okay, if you look here, there was always a 1 as our coefficient because those ones are coming out diagonally, and then it's always that number to that power. And the last one is then always 1 times b to the n. All right. From there, the exponent of the a. So as we look at our a's, what's happening to our a's exponent every time as we go from left to right? It goes down by 1, right? So the exponent for a decreases by 1 from left to right. But the exponent for the b does what? That goes up by 1 or increases by 1 from left to right. And then the sum of the exponents in each term. So if we look at each term, like here, if I'm looking at the third one, my exponent here is a 3. And then I have a 2 and a 1. What's 2 plus 1? 3. Then I have a 1 and a 2. 1 plus 2 is 3. And then I have a 3 again. Here I have the 5. 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And 5. So every term, when you add the exponents, it's always going to add to the n. Whatever it was originally raised to, those exponents always need to add to that. So, how can we do a plus b to the 6th written out with expansion form? So we already have row 6 of our Pascal's triangle because we just wrote that down. So just so I don't have to keep writing, I'm going to rewrite it up here. It goes 1, 6, 15, 20, 15, 6, and 1. Okay, so those are going to be our coefficients. Now, when you start, the first coefficient's a 1, and then it always starts with the a raised to that power. It always starts with a to the n, 1a to the n. So I'm going to start with 1a to the 6th. Now, I'm going to add to that, my next coefficient is a 6 from the triangle. And we said that a decreases by 1 each time. So the next exponent for the a would be 5. And our exponent for the b has to increase. So here is really b to the 0. Now it's going to be b to the 1st. And then we add to that, our next coefficient would be 15. We decrease our a by 1, so b a to the 4th. We increase our b by 1. And again, double check. Do all these exponents so far add to 6? They do. So far they do. We add to that the 20 coefficient. And that would be a to the 3rd, because I decrease the a by 1, increase the b by 1, b to the 3rd. And then we add the next 15, the next coefficient 15, take one away from the exponent of the a, which is 2, and add one to the exponent of the b. So 15a squared b to the fourth would be our next term. Our next coefficient is 6. We decrease 1 from the a, increase 1 for the b, so 6ab to the fifth would be our next term. And then the last term would be 1 b to the fifth, or b to the sixth, yes, b to the sixth. We decrease the a to 0, we increase the b to 6. And so that's all we needed to do for that one because all it said was a and b. So we're done with that one. That's the expansion for the sixth. But as you can see, the triangle is really what's making the pattern, okay? And it's not that hard. You just have to be kind of careful of everything. It's a little tedious, but not necessarily difficult.
Bro.
All right, so number 2, we have x plus 2 to the 7th power, or x plus 2 to the quantity to the 7th. So that means we're going to need to find the 7th row of Pascal's triangle first. No. So we got to find row 7 first. So we just did row 6 over here. So we come down and bring that 1, and then 1 plus 6 is 7. So our first numbers would be 1, and then 7. And then we have to add those. 6 plus 15 is 21. And then we're adding 20 and 15, 15 and 20 here, which is 35. And then adding at 20 and 15. So we're going to have two 35s in a row. And then we have 15 plus 6 is 21. 6 plus 1 is 7. And then the 1, yep. And then using the expansion, now that we have that expansion, if we said a plus b to the 7th power, that would equal coefficient of 1, so it'd be a to the 7th, because we always start off with 1a to the n, so it'd be 1a to the 7th, plus our coefficient 7, a to the 6th, b to the 1st. Again, we subtract our b and subtract 1 from our a, add 1 to our b, plus 21, subtract 1, so 5, add 1 to the b, 21 b to the 5th, a to the 5th, b to the 2nd. We're adding the 35, subtract 1 from the a to the 4th, b to the 3rd. We have to have the other 35, 35, a to the 3rd, b to the 4th. We have the 21, a to the 2nd, b to the 5th. Add to that the 7, a, b to the 6th. And last but not least, it would be 1, b to the 7th. So yes, that is long. But if you couldn't, if you, life. So yeah, we're not done yet. This is just the expansion. So now, since we actually have numbers in here, now we actually have to say, all right, the a is equal to x here, and the b is equal to 2. So now we have to put x in for the a's and 2 in for the b's. Yes, code man. Yes. Yeah, that's what I was about to say that. All right, so again, anywhere there's an a, you're putting an x. So it'd be x to the 7th plus 7, and then it'd be x to the 6th. So I'm putting an x in for the a, and then times b, which is going to be 2. So that's what we have so far. We've taken care of the first two terms so far. Then I'm adding to that the 21 Instead of a, I'm putting x to the fifth. And then instead of b, I'm putting 2 to the second. And then instead of that, I'm doing 35. A, I'm putting x, so it'd be x to the fourth. And then 2 to the third. And then I have my other 35 plus 35, x to the third. And then instead of b, I'm putting 2 to the fourth plus 21, x to the second, 2 to the fifth. Running out of space here.
Yeah.
Plus 7x times 2 to the sixth, and then plus 2 to the seventh. So once we have that, now we just have to take any exponents and multiply, okay? Because we're not going to have any other like terms. So we have x to the seventh, and then our next one, I'm doing 7 times 2, which is 14, and I still have x to the sixth. So far I have x to the seventh plus 14x to the sixth. As I go to this next one, I have to take 2 squared first, which would be 4. And then I can do 4 times 21, which would be 84. And then we have x to the fifth. Adding to that, 2 to the third is 8. So this is where you might want to start getting a calculator out. 8 times 35. Good. 280, good. And then we have that would be times x to the fourth. Add to that, 2 to the fourth is 16. 16 times 35, 560. X to the third. 2 to the fifth is 32. 32 times 21, 672. X squared. 2 to the sixth is 64. 64 times 7, 448x. And then last but not least is 2 to the seventh, which is 128. So yeah, that's a long one, and that's the seventh power. That's pretty long. But still, we were able to do that. Imagine if you had to write x plus 2 times itself 7 times and then multiply that all out. That would be so messy, and it would take a whole piece of paper, and you'd probably make a mistake somewhere. Okay? So that is definitely a shortcut. And then we'll do one more together. So if we look at for number 3, we have 3m minus 1 quantity to the fourth power. So with that being said, we can either create our binomial expansion using row 4, 1, 4, 6, 4, 1, which I'll do. 1, 4, 6, 4, 1. And so that would give us a to the fourth plus 4, a to the third, b to the first, plus 6, a to the second, b to the second, plus 4, a to the third, b to the first, plus b. I messed this one up. Hold on, sorry. B to the second. This should be a to the first, b to the third, and this would be b to the fourth. So that's our expansion. And now for a, we are putting what? 3m. And in for b, we are putting -1. Notice how we just put plus signs for everything? So this is now important that you're going to actually put the negative number if it's negative, okay? So that would give us a to the fourth. So be careful here because we have to put 3m all in parentheses because we're raising that whole thing to the to the fourth. 3m to the fourth. And then plus 4. I'm taking a to the third. So I'm, again, raising 3m now to the third. The whole thing raised to the third. And I'm raising b, which is -1, to the first. And then I take the 6, which is next, 3m to the second, 3m quantity squared, -1 squared. And I'm putting 3m for the a, so that'd be 4 times 3m, and then that would be -1 to the third, and then last would be -1 to the fourth. Okay, that's the hardest part, because now it's just multiplying and taking exponents. So for the first one, I would have to take 3 to the fourth. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So we'd have 81 m to the fourth for that first term. Now for this second term, I have to take 3 and cube it. So that would be 27 m cubed from this piece. And -1 to the first is just -1. So I'd have to do, what's up?
Didn't you already use that for when you got the 3 to the 81?
No, I used this. It was the fact that it's raised to the fourth power that got me the 81. The whole quantity is raised to the fourth power, so I have to raise each one to the fourth.
Oh,
Okay?
yeah.
So for this second term, I'm doing 4 times 27 times -1. So that would be -108 m to the third. For my next term, I will be doing 6, 3 squared is 9, m squared, and that -3 should also be raised to the second, if I missed that. Make sure you have that to the second. I think I'm going to blame that on my pen. I think my pen didn't copy that down. -1 to the second is +1, right? So I'm doing 6 times 9 times 1, which is +54 m squared. And then this one, I'd be doing 4 times 3m times -1. -1 cubed is -1. So 4 times 3 is 12, times -1 is -12m. And then what's -1 to the fourth? +1. So that one's not quite as bad because it's just the fourth. Don't expect a seventh power on your test. Okay, I'd say a 4 is fair. Maybe a 5. I don't know. All right, now the question always comes up. Well, are we gonna get that pink sheet on our paper, on our test or quiz? Well, no, because you can create that same thing using your Pascal's triangle. So the binomial squared, like when we had on our triangle, on our pink sheet, we had a plus b squared. If we look at row 2, 1, 2, 1. So it's square our first plus 2a to the first, because I subtract 1 from that, and I put b to the first, and then plus b to the second. Those are my exponents. Or the a plus b to the third. That was the other thing on our pink sheet. Well, using our row 3, 1, 3, 3, 1, we would have a to the third plus 3a squared b plus 3ab squared, and then plus b to the third. So you should all know how to create that now in Your brains. Wild. All right, so I want you to try the following three as in class / homework. So I want you to change 5 and 6. I'll make them a little easier for you.
Oh. 8.
No, I'm changing them, making it a little easier for you. All right, so 5 is going to be x plus 3 all to the 5th power. And then I'm going to make number 6 be 2x minus 1 raised to the 4th. Okay. So try 4, 5, 6. I'll be around if you have questions or need help. As for the quiz, if you want to take it tomorrow, the second part of the period, you're more than welcome to. If you're like this Pascal's triangle stuff is easy, cool, you can take it tomorrow. I posted the review on Google Classroom, the answer key. Pascal's triangle was not on the review, but that's what we're working on now. We'll review it a little bit more tomorrow. If you want to take it Monday, first part of the period, that's fine also. Okay, so you decide on that.